Today we are solving LeetCode 53 maximum subarray. This is a very important DSA problem because it teaches one of the most important algorithms, Kadane's algorithm. In this problem, we will learn 5 key concepts. What is a contiguous subarray? How to think about maximum sum problems? Why brute force becomes too slow? How Kadane's algorithm works in order n? How to handle negative numbers carefully? Let us understand the problem first. We are given an integer array nums. We have to find the contiguous subarray with the largest sum and return that sum. Contiguous means the elements must be continuous. We cannot skip elements. For example, nums equal to -2, 1, -3, 4, -1, 2, 1, -5, 4. The answer is 6 because the subarray 4, -1, 2, 1 that has the maximum sum, as you can see in the example. Now let us first think about the brute force method. In brute force, we can try every possible subarray. We fix a starting index I, then we move ending index j from I to the end of the array. For every subarray from I to j, we calculate the sum and update the maximum answer. So let us write the pseudocode for brute force. We initialize maximum equals infinity. Then we run the loop for I equal to 0 to n minus 1. We set current sum equals 0. And then we run another loop from j equal from I to n minus 1, and we keep adding current sum. Finally, we return the maximum. The maximum is maximum and current sum. So this is a very simple very simple logic that we loop from I equal to 0 to n minus 1, and then at every I we start another loop from that element to the end of the array. Then we check the sum of the subarray that's formed from I to j, and we take the maximum of that sum. But the solution takes order of n square times because we are checking all possible subarrays. Since nums dot length can go up to 10 power 5, as you can see in the constraint, it can go up to 10 power 5. So order n square will be too slow. So now we need an order n solution. So this takes time equals. Since this is where Kadane's algorithm comes in. The main idea is simple. At every index, we ask one question: should I continue the previous array, or should I start a new array from the current element? Suppose we are standing at index I. We have two choices: nums I, start a new array from current element, or current sum plus nums I, continue the previous array. So the formula becomes this. At every I have two choices. Start a new First choice is start a new subarray, and second choice is continue the previous subarray. So if my current num psi will be greater than the current sum plus the num psi, then obviously I will leave the previous array and start with a new one. So this is the formula, and after that we update the answer. We update the answer like this: maximum equal to maximum and current sum. Here current sum means the maximum sub-array sum ending exactly at the current index, and maximum means the best answer found so far. So let me write it out. Now let us write the Python code. So current sum equals num0 and maximum equals also equals num0. Then we run a loop for I in range 1 to len nums. We start from 1. Then we keep updating current sum and also the max sum. And we finally return max sum. So this question is very simple. Let us see how this is being done by a dry run. By dry running an example. Let's say our nums is this. Initially, current sum equals -2 and max sum equals -2. So initially, now we move to index 1. So nums1 equals 1. We move to I equal to 1. So now nums1 is equal to 1. So should I continue? So -2 plus 1. My question is should we continue or start fresh? Or let me simply write current sum will be updated in this manner. So it is maximum of nums1 and nums1 plus current sum. So that is equal to 1. So current sum will become 1 and maximum will become maximum current sum and maximum. So that will also become 1. Now at I equal to 2. My question will be, should I continue with the new num psi or should I continue with the previous sum? So current sum will become 1 because 1 plus -3 is less than 1 and maximum will also be 1. It is maximum current sum and maximum. Now at I equal to 3, let me delete it from here. This will keep on going for all other indexes. So let us complete the dry run. For I equal to 3, current sum will become 3 is this 4. So 1 plus 4, that is 5. So current sum will become 5 and max sum will also become 5. Now for I equal to 4, nums4 equals -1. So nums4 equals -1. So current sum will become, because we will decrease the previous current sum, so it will remain as 5 and max sum will also remain as 5. Then for I equal to 5, nums 5 equals 2. So current sum will become 5 plus 2 is 7. Okay, so it is num psi or current sum plus num psi. We are taking max of num psi and current sum plus num psi. So at I equal to 3, current sum was equal to 4. I think we need to restart this. Let's start from I equal to 1. At I equal to 1, my nums1 equals 1 and current sum equals max of nums1 and current sum. That is equals max of 1 comma minus 2. So equals 1. And max sum equals max of current sum 1 comma max sum. So that becomes equals 1. Now for I equals 2, nums2 equals minus 3. Current sum equals max of nums2 and the current sum. Current sum was equal to 1. So it will become 1. That is the logic. Max of num psi current sum plus num psi. So it is not current sum, it is current sum plus num psi. Okay. Current sum plus nums1. So current sum plus nums1 is minus 1. So it will become 1. And here it will become current sum plus num psi. So that will be minus 2. 1 plus minus 3 minus 2. So it will become minus 2. And max sum will become max of 1 comma minus 2. So it will remain as 1. Now for I equal to 3, nums3 equals 4 and current sum equals max of nums3 comma current sum plus nums3. Let me delete this. That is max of 4 and current sum was minus 2. So minus 2 plus 4 is 2. So it will become 2. And this will take the max sum and the current sum. This will also become 2. For I equal to 4, nums4 equals minus 1. Current sum equals max of minus 1 and 2 minus 1, 1. So that is 1. And max sum will become max of 2 current sum comma the max sum. So it will remain as 2. Now for I equal to 5, nums5 equals 2. Current sum equals max of nums I, that is 2, and the current sum plus nums I, that is 1 plus 2 equals 3. 1 plus 2, so it will become 3. Then it will take max of the previous max, 2, and the current sum, 3, so it will become 3. Now for I equals 6, nums 6 equals 1, current sum equals max of nums 6, comma current sum plus num 6. So 3 plus 1, it will become 4. And this will give you max sum. Max sum equals max of the previous max sum and the current sum. So this will also become 4. Now for I equals 7, nums 7 equals minus 5. Current sum will become max of nums I, that is minus 5, and current sum plus max I. So 4 plus minus 5, 4 minus 5, that is minus 1. So it will become minus 1. And maximum will take compare the previous maximum and the current sum. So it will become 4. Now for I equal to 8. So nums 8 is equal to 4. Current sum equals max of nums 8 4 and 4 minus 1 3. So it will become 4. And max will become the max of 4 comma 4. So it will be 4. So we are getting this as 4. Maybe we have made some mistake somewhere else. Correct answer should have come. The idea is extremely simple. Current sum gives us what is the largest sum that I can get from a subarray that is ending at index I. So if you check current sum for different indices, so current sum for I equal to 0 will be minus 2, for 1 it will be minus 1. Similarly for all the, and for in the example we can see that this one has the largest sum, 4 minus 1, 2 and 1. But for I equal to 6, I think we have got the wrong answer. So you can check it on your own. But I hope you have got the idea. In case you have any confusion, then you can write in the comment. I will resolve it. So let us try to run this code. Okay, it passes. And let us briefly discuss its time complexity. So time equals order, and because we are running a single loop from I in range 1 to n, the length of the nums array. So it is of order n, and space is equals order of 1 because we are not using any separate array, just a few variables. So let us now submit it. Let us discuss one important edge case. What if nums equals? It is great that all the test cases are passed. Uh, let us discuss this one edge case. What if nums equals minus 3, minus 2, minus 5? That is, all numbers are negative. So the answer should be minus 2. Answer equals minus 2. because the maximum subarray must contain at least one element. That is why we initialize current sum equals num0 and max sum equals num0. We should not initialize them with 0. If you initialize with 0, then for all negative arrays, the answer may wrongly become 0. Now let us also understand the divide and conquer approach, because this is mentioned in the follow-up. In divide and conquer, we divide the array into two halves. The maximum array subarray can be in one of three places: completely in the left half, completely in the right half, crossing the or crossing the middle. So we calculate left max, right max, cross max, and return max of left max, right max, and cross max. The crossing sum means best sum ending on the left side of mid plus best sum starting on the right side of the mid. So let us write it in detail. This was an edge case. Now let us do the follow-up. We divide the array into two halves. This is the idea. And the maximum subarray can be in one of three places. The maximum subarray that we are finding can lie in one of three places. So these are the three places. So first can be completely in left half, completely in right half, or crossing the middle. So we calculate left max, right max, and cross max. The crossing sum means best sum ending on the left side of mid plus best sum ending on the right side of mid. So let us write the Python code for this divide and conquer approach. This is our base case. If left double equals right, then we return the nums left. If we haven't reached the base case, then we find out the mid. Then we find left max, then right max. So for left max, we do the same. We call the same function solve, but with different parameters. Similarly for the right max. Now what we do is we find the cross the sum. So left sum equals this in current equals 0. For I in range mid to left minus 1 going backward, we keep doing this. And we set the right sum in the same manner. And finally we find the cross max. Left sum plus right sum. So in this way we have found the cross max also. Now we return the maximum of the three. So what we have done is, first, this is the base case. Then we find the calculate the mid. Then we find compute the left maximum in the left half, maximum in the right half. Now we find the maximum in the cross. That is, one index lies in the left half and the other index lies in the right half. So for that, we initialize left sum equal to minus infinity and current equals to 0. Then we loop through the left half, keep on adding num psi in current. Then we find the left sum equal to max of left sum in comma current. Okay, so what we've got is we are getting the uh, greatest value in which ends at the mid and starts in the left subarray. Similarly, we do for the right, which starts at mid plus 1 and ends at right, ends in the right subarray. Now, when we join them, then we get the maximum possible value with the index which starts in the left half and ends in the right half. So that's how we have got the cross max. And finally, we are returning the maximum of left max, right max, and cross max. So that is it. And we are calling the solve for the complete array, the function that we have written. So initially 0 and final and index is there. So that's it. The time complexity of this approach will be n log n because we are doing it in a similar way as merge sort. That's why it is n log n. At every level, we process the array, and there are log n levels. So n amount of work is being done at every level, and log n levels are there. That's why the answer is in n log n, and the space complexity is log n because of the recursion stack. But for interviews and LeetCode submission, Kadane's algorithm is the best solution here because it is order of n time and order of one space. Let us also try to submit this and see what we get the result. First, let's try to run with the test cases. It shows an error written outside the function. Okay, test cases passes. Now let us submit it. Okay, so this also passes, but it only beats 5.97%. Memory wise, it was not good because it takes order of n log n time. If we try to submit the previous version of our solution, then it beats around 100%. Okay, 50%, fine. Memory beats 73%, so both is better. Now let us discuss critical mistakes. First is initializing answer with 0. So this fails when all numbers are negative. Mistake number 2 is thinking subarray means we can skip elements. We cannot skip elements, the subarray must be contiguous. Mistake number 3 is confusing current sum with and max sum. So already I have repeated it many times. Current sum means best sum ending at the current index. Max sum means best sum found anywhere so far. Mistake number 4 is not starting the loop from index 1 when current sum and max sum are initialized with num 0. If we initialize from num0, then the loop should start from index 1. Mistake number 5 is forgetting that one element alone also can also be the answer. For example, when nums equals 1, the answer is 1. To recap, we solved LeetCode 53, maximum subarray. We first understood brute force, then we optimized it using Kadane's algorithm. The key idea was, at every index, decide whether to continue the previous subarray or start a new one. This gives us order n time and order 1 space solution, and this is why Kadane's algorithm is one of the most important patterns in DSA.